Now for part 12. Moving right along, we're about to discuss domain and codomain swap. But first, a proof. A function f is surjective. To start off, definition of a surjective function, also known as an onto function, says a function f where set A maps to set B is surjective if for every y in B there exists an x in A, such that f of x equals y. To unpack that, the notation f of x equals y is the general way to define a function where each input x from the domain maps to an output y in the codomain. It's a general, abstract notation for any function mapping inputs to outputs, compared to f of x in the blue box, where it's a specific, concrete rule for a particular linear function. So the notation f of x equals y only states a specific input x maps to a specific output y. To determine if a function is surjective, we need to analyze the rule of the function and compare its range, which is the set of all the actual outputs, to its defined codomain, which is the set of all allowed outputs. So the notation f of x equals y sets up the relationship, while the specific rule in the blue box combined with its domain and codomain, which you'll soon see, determines whether that relationship is surjective or not. In simple terms, the range of the function is equal to its codomain, or sometimes you'll hear the range covers the codomain. So you might have guessed the function we want to see if it's surjective or not, the blue box, which should look familiar from the previous video. It's a function f where degrees in Celsius maps to degrees in Fahrenheit. We think we can show every value y in the codomain there exists at least one value x in the domain such that f of x equals y. So we're assuming the function f is defined over the real numbers, where r maps to r, the white box. Then we have the specific rule, the blue box. We want to show the range of f is equal to its codomain, which is capital R. Here you might be asking, why even have a codomain when its range is the actual values? We asked a similar question in one of our first videos of the series. We discussed reasons for a codomain. One good reason could be for a formal definition of a function, as a function is formally defined by its domain, codomain, and the rule that maps inputs to outputs, such as the blue box. So the codomain is a fundamental part of this definition, as a function is a relation between two sets, the white box, and the codomain is the set into which the output values are constrained to fall. In our experience, especially in linear algebra, defining its domain and codomain is helpful to analyze a function. Enough said. First orange bullet. Then we set f of x equal to an arbitrary element y from the codomain. We want to demonstrate we can always find a corresponding x value such that y equals 9 over 5x plus 32. Here, the two terms of f of x now equal each other, where y equals the specific rule. Like a equals b and a equals c, here b equals c. Now we want to express x in terms of y. First, subtract 32 from both sides, then times each side by 5 over 9, which returns x equals 5 over 9 times y minus 32. See that? Consequently, we found an expression for x. That's crucial because the next step, we need to verify if x is in the domain. Here we can reason, since y is any real number, the expression in the yellow box in terms of y will also result in a real number. Thus, for every y in the element of the reals, the corresponding x is also an element of the domain of capital R. The last step, ladies and gentlemen, we need to verify the mapping. For that, we substitute the expression for x back into the original function f of x to show it indeed maps to y. Second column, doing what we just said. Let's find f of 5 over 9 times y minus 32. Essentially, it operates like a composite function. Replace every instance of x in f of x with the term in the yellow box. Then simplify, doing some mental math, times the brackets with 9 over 5, shows the product of itself and 5 over 9 just cancel each other. Next, undo the brackets, which just leaves y minus 32 plus 32, which just returns y. Almost there. Last bullet. We have f of x equals y, which is what we want. We can conclude, since for every y in the codomain R, there exists an x in the domain R, such that f of x equals y. Therefore, f of x equals 9 over 5x plus 32 is surjective. Nice.